right, students. So what we're going to do here is it's going to be, I'm sure, a series of screencasts because this is a long note sheet. Bear with me. And really, you need to print out this note sheet and you need to work along with me, pausing the screencast to try things on your own, to work ahead, to make sure that you're understanding things as we go through this. So the first thing I need to do is explain why we're going to do what we're going to do. So we're going to start working with numbers that are not in base 10. And I know you don't know what that means yet, but you will. And we don't do this just because I want to torture you or whatever. It is impossible for you to unknow what you know about base 10. If, I write down a number like 415, so I put 415, it's automatic that you realize, just how many, what that quantity is. And we need to shake you up so that you begin to understand what it's like for your students to learn base 10 for the first time. It's not easy. So as you learn these different bases, it's going to help give you insight into what it is your students need to understand to have a really good handle on base 10. We're going to be continuing with these non-base 10 numbers even into the next modules, so they're going to keep coming up over and over again. So this is really important for you to get good at. All right, so let's get started on the note sheet. So on this note sheet, there's a note here. It says, George showed the following base blocks to represent the number 4,256. Now notice these do not look like the drawings of the base 10 blocks that we were looking at before. These are what are called shortcuts. So instead of, trying to draw a cube, we instead just make a dot. It's a whole lot easier. Instead of, trying to draw along, okay, my pictures are terrible, I'm sorry, and showing, all the divisions, I'll probably not get 10 in here, we just draw a straight line. And so when we draw the straight line, we are inferring that we have this. This right here is, if I had a flat that would have, the grid lines both directions. So this is just a shortcut. This is a block. So we often call these shadows when I'm teaching face-to-face. So this is a representation of that 3D where you take 10 of these guys and you put it together. So we're going to be using these shortcuts from now on. Okay? All right, so my first question is, do the base 10 blocks represent the correct cardinality for 4,256? Well, let's take a look at this. It's going to be worth our time to do this kind of slowly. So if I look at this piece right here, that's worth 1,000 units. That's worth 1,000 units. 1,000 units. Each of these guys is 100 units, right? So I'm going to put 100 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right? Each of these guys is worth 10. So this is going to be 10, and I've got 4 of them, times 4. And then I'm going to count up my units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Lost count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right. So this is 3,000, right? 1,000 or 100 times 12 is 1200. That's 40. This is 16. So if I take 3,000 and I add 1,200, and then I add 40, and then I add 16. So I've got 6, 5, 2, 4. Yeah. All right. So this is a correct representation. It's the correct cardinality. And we'll yet let my drawings and my notes up here be my explanation. All right, so now the next question is George's representation using base blocks correct for our base 10 number system? All right, so hopefully you're answering that question in your head. No, it's not correct, because he is showing that we have 12 100s, and he's showing that we have 16 ones. And in our base 10 number system, we do an exchange. So we don't have more than 9 of any given base piece without doing an exchange. So our answer here is no. You wouldn't have, 16 ones or 12 hundreds. The cardinality's right. It's just if we want to be able to translate from our base pieces to writing the number correctly, this isn't correct. Okay, so we'll work on that on the next page. So what is the rate for composing and decomposing place value units in our base 10 number system? So our unit is, our conversion is 10 to 1. So if we take a piece and we break it into its components, we get 10. If we want to make the next bigger piece, we need 10 pieces. Right? What digits do we need for our base 10 number system? Well, we need 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are our digits. Right? And our place value in base 10, the way I like to do this is make lines and label them. So these are my 1s, 10s, 100s, 1000s, and it keeps going forever. Okay. All right, so how should George fix his base 10 block representation? Well, we need to do an exchange here. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's see if I can get this right. So what I want to do, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to take these 10 ones, and I'm going to turn that into a long. I've got these 6 ones here. They're going to have to stay in the ones column. They don't have enough to jump over here. I've got 1, 2, 3, 4, 5 10s now. I'm going to leave that be. All right. Now I had 12 of these hundreds, and I need to take 10 of them, and I need to turn it into a thousands piece, a block, a shadow, however we want to call it. Okay. I've now fixed my representation, and we can see that my representation matches our symbolic way to write the number. So I've got 4 in the hundredth spot. Let's say that again. How about 4 in the thousand spot? And I have 2 in the hundredth spot. And I have 5 in the 10 spot, and I have 6 in the 1 spot. So going back, George's representation here was correct. However, correct cardinality. All right, he represented 4,256 ones the way they were put together. If I broke these apart, that's how many ones there would be. But in terms of symbolically recording the number, he didn't do a good job. He didn't follow the 10 to 1 ratio. And that's what we've changed here. And so now we can see that our base pieces match up exactly to the way we symbolically write the number, 4, 2, 5, 6. All right, so I'm going to go on to the next page here. And all of a sudden, we're going to start changing bases. And there's really no easy way to do this. We're just going to jump in. We're going to do a lot of examples So if you feel a little fuzzy on the first one, it will get better. So kind of bear with me on this. We're going to work in base 5 now. All right. So when we do base 5, the rate for composing and decomposing place value units, right? When it was base 10, it was 10 to 1. So if we're in base 5, it's going to be 5 to 1. In terms of the digits, compare this to base 10 again. When we did base 10, we needed 0 through 9. 0 through 9 is 10 different digits. When we do base 5, we're going to need 0, 1, 2, 3, 4. We don't need a 5 because if we ever have 5 of something, that's our exchange rate. Okay? What is the place value? What is the value of each place value in base 5? Okay, so here's where things change up. And this is all based. Okay, and I'll probably put that in a bad spot, but oh well. It's all based on this exchange rate. Right, these are still the ones. Right, but now when we compose the next higher size, it takes 5 of them. So when we get 5 ones here, we turn them into 5s. When we get 5 5s, 5 5s is 25. We take 5 5s and we turn them into 25s. 5 25s, okay, when I get 5 of these 25s, I turn them into 125s. Let's go one more place value. If I take 5 125s, those get turned into 625s. And this could keep going and going and going. Okay? So, the next question, which I covered up, but I know you can see it on the note sheet that I'm sure you printed out. I hope you are. What is the value of each base piece? So we start using base pieces for different bases, and we use these shortcuts because the visual really helps people, right? So when we draw shortcuts for base 5, we all have in our head that, hey, our babies are still 1s. But when I draw a long, that's equal to 5. So you can imagine it being an actual, looking piece, and it would be 5 of the little squares into 1. Okay. When I draw a flat, okay, my flat is equal to 25. And when I draw shadow, okay, or a block, that is 125. Right? And several years ago, students really depend on these base pieces sometimes to help them work in these different bases. Sometimes you have to use even bigger pieces, and this is student made, but it made perfect sense to me, so I'm okay with it. If you needed a bigger base piece, which wouldn't physically exist, but that's okay because it does what we need it to in our brains, we'd put a double shadow on it, and that would be 625. And if we went bigger, we'd put even another shadow, and so on and so on. Okay, so now we're going to represent this as a base 5 number. All right. I have 1 minute left in this screencast, so I'm going to have to pick up in the next screencast.